Hello everyone, welcome to AP Calculus. In this video, we are going to cover one of the important tests that is called root test, which we will be using to check whether a particular series converge or diverge. Now this test is also known as the Cauchy root test, and it is used to calculate whether it is a series is converging or diverging, and generally we use this test in these types of series when we are having k raised to the power n, any constant raised to the power n, or any general term raised to the power n, or we are having a power series. In these types we use this thing. So let's understand what is the definition of this. The definition says if any series is given to us, let's say sigma an and goes from 1 to infinity, the infinite series is given to us. First we will calculate the nth root of absolute value of this an. This is the nth root of absolute value of this an, and then we will calculate the limit n goes toward infinity. This is the general expression for this. Now when we are getting this result, there can be three types of result. Either the result is less than 1. If the limit comes out to be less than 1, then we will say the series converges absolutely. If the result is greater than 1, or you can say infinity also, we will say series diverges. But if the result is equal to 1, the test is inconclusive, and in that case we have to use any other test also. So let's understand when this test is the best one. When you are having this type of pattern, an raised to the power of n, the power series looks like this, sigma an x power n, when the factorials and the exponentials are combined, and in these types of series when we are having n to the power of n along with some constant. Sometimes the ratio test we can also use in this. So let's understand with the help of some of the questions. If you look at the first question, it says we have to check whether this particular series converges or diverges. So here it is having power n power n. So first let us calculate what is this expression an, nth root of this thing. So nth root means e raised to the power 2n divided by n power n whole power of 1 by n. The exponent will get multiplied. If exponent will get multiplied, it will be e square over n. Now we will calculate limit n tends to infinity for this e square upon n. Now here we can clearly see that e square is just a constant, n goes toward infinity, so denominator is getting very large. If the denominator is getting very large, so this will be 0. So I know since 0 is less than 1, so therefore I will say this particular series converges absolutely. A very easy method. Let us take another one. Here also this is the hint. This some an is there and power of n is there. So again first we will calculate this thing. So what is this an over here, and absolute value of this? Actually in this previous one also we have to put the absolute value. So absolute value of this an. So absolute value of this thing means minus 3n whole upon 2n plus 1 and this, and whole power of 1 by n, and there is an absolute value inside this. So the n will get cancelled out, and when we take the absolute value, the negative becomes positive also. So it becomes 3n divided by 2n plus 1. Now we will calculate limit n tends to infinity for this thing, 3n upon 2n plus 1. Now you know that it is n is going toward infinity, and this is polynomial divided by the polynomial. When we are having polynomial divided by polynomial, we will check the degree of the numerator and denominator. If the degree is same, right now the degree is 1 then directly we can say that the ratio of leading coefficient is the answer. So if the ratio of leading coefficient is 3 divided by 2, so I know since 3 upon 2 is greater than 1, so therefore this particular series diverges. Let's take one more, n divided by 2 power of n. So here again we will calculate nth root of absolute value of this. So nth root of this thing means n divided by 2 power n whole power of 1 by n. It's already positive, so absolute value will be the same. So it is n power of 1 by n divided by 2. Now we will calculate this particular limit. So here it is, if we apply this thing, limit n goes toward infinity and n power of 1 by n divided by 2. Now when the n goes toward infinity, so it is what? This base is going toward infinity, and 1 upon going toward infinity is going towards 0. So basically it is infinity to the power of 0 going towards infinity to the going towards 0. So this is the indeterminate form. Directly we cannot conclude what is the answer. So let's understand how to solve this particular limit. So n to the, I am only solving n to the power of 1 by n. So I will say let y is equal to limit n goes to infinity n to the power of 1 by n. Whenever we are having infinity power 0 or 0 power 0, we can apply the same method every time. So first take the ln on both the side. So if you take the ln on both the side, according to the property of the natural log, this exponent comes into the multiplication. So this 1 upon n will come into the multiplication, ln n is there. So basically it is now limit n goes to infinity, L of n divided by n. Now if you put the limit n goes to infinity, denominator is going toward infinity. What about the numerator? So ln, if you look at the graph of ln x, it's like this. So when the n is going toward infinity, the value of ln n is also going towards infinity. So it is going toward infinity upon going toward infinity. So I am going to apply the L'Hopital rule. According to L'Hopital rule, what we have to do, we have to differentiate the numerator and differentiate the denominator. So if you apply this thing, differentiate the numerator, differentiation of the numerator ln n is 1 upon n, differentiation of the denominator is what? Differentiation of denominator is only 1. Now basically it becomes n goes to infinity 1 upon n. So if the n is going to infinity, so we can say 1 upon n will go towards 0. So now the answer is not 0 because on the left hand side we are having ln of y. So from here we can say if ln of y is 0, so therefore y is equal to e raised to power 0 and e raised to power 0 is 1. So y is equal to 1. So we are having this particular part. The numerator is going towards 1. So numerator is going towards 1. So finally it is going towards 1 upon 2. Right? So if it is 1 upon 2, so we know it is less than 1. So therefore we will say converges. Converges absolutely. But this question can be easily solved with the help of the ratio test, n upon 2 power n, right? So let's say using the ratio test it will be much easier because we are having the question limit n goes to infinity n upon 2 power n. According to the ratio test, what we will do? We will calculate simply this thing, absolute value of a n plus 1 divided by a n. So what is a n plus 1? N plus 1 upon 2 to the power of n plus 1 divided by the original one. When we divide by the original one, it will get reciprocal. So 2 power n over here and n over here. Now if you simplify this thing, limit n goes to infinity. So let's simplify. 2 power n and 2 power n will cancel each other. So it will be only 2. And here we will be having 1 by n plus 1 upon n. Now again if the n is going toward infinity, so we have this polynomial upon polynomial, degree is same, so ratio of leading coefficient is the answer. Leading coefficient is 1 1. So finally it will become 1 by 2 only. This part will become 1 and we will be left with 1 by 2, and 1 by 2 is less than 1 according to the ratio test. So we'll say it converges again. Converges absolutely. So in this method the ratio test was easier as compared to the root test. So I hope you have understood this root test. So if you like this video, please subscribe to the channel and thank you for watching this.